AWS software library for modeling and simulation of solar desalination systems. www.retslibrary.com.
Hi everybody, Professor Mohammed Sharaf with you. Let's today talk about clearly discuss solar radiation models. What is the concept of such models? How many types? How should or how can we run such analytical model or mathematical models by the use of Rets library? Okay, the main concept is just that Earth receives about 174 petawatts of incoming solar radiation, insolation global, at the upper atmosphere. Okay, approximately about 30% is reflected back to the space, while the rest is absorbed by clouds, ozones, oceans, lands, masses, and so on. For the total solar energy absorbed by Earth's atmosphere, oceans, and land masses is approximately about 3 million or nearly 4 million exajoules per year. Therefore, solar energy can be harnessed at different levels or harvested at different levels around the world, mostly depending on distance from the equator or solar beam. Okay, this chart presents or shows the distribution of the incoming solar radiation. Part of it reflected by the atmosphere, clouds, Earth's surface, and so on. And just we have to receive about 89 or 90 petawatt absorbed by the land and oceans. For world solar radiation map, it shows the solar beam, especially Africa, clear example of global horizontal solar radiation for the global on horizontal surfaces for kilowatt per meter square per day. As you can see here, Africa shows that places such as Egypt, Mauritania, especially in North Africa region and the middles of African continent, Saudi Arabia, Gulf region, have a massive solar radiation energy. It's around from 5 up to 8.5 kilowatt hour per meter square per day. This is a massive and huge energy that we can estimate or calculate. Okay, how is it measured? Okay, solar radiation is measured with a complicated device. It's a pyranometer. Traditionally, this device consisted of special sensors composed of multiple thermocouples and embedded in a special material or something like this. The basic goal is to absorb the entire solar spectrum. That's the main idea of such configuration, such device, is to absorb the entire spectrum of the solar radiation beam. Okay. Today there's many types of such devices, digital devices and analog devices and so on. Okay, for how we can measure solar radiation or per meter square or daily average or monthly average, but analytically or mathematically. Okay, there is many of solar radiation models. It is important for many solar energy systems to estimate and to predict the instant or daily mean direct, also diffuse radiation on horizontal or tilted surfaces at any specific location. Analytically, there are many mathematical approaches about how to calculate solar radiation. For example, Asher model, Davis enhances, bird model, equal model, what height hotel, and so on. The main target of such techniques is to calculate solar radiation angles based on local solar time, clock time, standard meridian, sure longitude and latitudes, and equation of time, and the main target of such configurations, just some examples, is to calculate the zenith angle. This is most important parameter of such a configuration. Okay, how we can how can we run solar radiation models? We have developed by Red's library a specific model in order to calculate solar angles, instant solar radiation for a specific location per meter square, diffuse and global beam, direct normal radiance, hourly, daily, monthly average, megajoule per meter square, and we can compare between some specific solar radiation models. We choose Ashria, Twitter and Pole, equal hotel models in order to compare between each other. Okay, open your MATLAB, go to your destination folder, okay, and begin your model. Okay, this is our model. First of all, we have to double click. Okay, we can visit YouTube page for some tutorials, some description about the model and so on. Okay, this is a Julian day of the year. We can choose. Okay, February represents the day number 32, March day number 60, and so on. December, last day of the year. Okay, we have to consider the current time hour. We can put one value. Okay, suppose I need to put to measure the watt per meter square at 9 o'clock, 8 o'clock, 7 o'clock, 12 o'clock. Okay, a specific hour, but I prefer to put it in a matrix with step 10 minutes up to 4 o'clock afternoon. Okay, day number. Okay, we have to choose our day number. Suppose in summer, so in summer, July, day number 1 to 8. Okay, you can choose between many countries around the world wide. Suppose I'm going for example of Egypt, for example, yes, Egypt, Cairo. Okay, standard meridian around 30-31. This tilt angle, you can choose your tilt angle. Sea level, it's around 70 meters. Okay, kilometer, and we have to choose between 4 solar radiation models. Suppose I am going for a hotel model. Let's see. Okay, this is hotel model. Okay, yes, this is hotel model. Okay, we are going to measure the global, I mean the diffuse and DNI solar radiation model. Let's run our model now. Okay, this is our model. This is our specific data. I have to let's turn back again here. Yes, let it be step 1. Step 1 in order to show our matrix. And let's run our model again. Okay, This is the starting day hour, watt per meter square, starting day at 8 o'clock, 9, 10, 11, 12. This is the midday hour. Okay. For solar radiation angle, we can found the following: extraterrestrial intensity, okay, sun temperature, Kelvin, equation of time, solar time hour, sunrise time, sunset time, okay, how many days hour for solar radiation, hour angle, solar altitude angle, okay, declination angle. Okay, suppose we are going to choose another location, but before this we have to, for daily solar radiation, megajoule per meter square. This is hourly received global radiation. Okay, this is monthly average daily total. Okay, this is monthly. Okay, okay. For another location, suppose I'm going for example, China. Okay, suppose China. I think standing it's around 120 or 105. Okay, for the same model. Okay, let's see. Okay, this is China, solar radiation angle. Okay, different. Okay, we can choose different Julian day. It's easy. It's easy. I mean, let's go for April 91. Let's go for April. Let's choose another one. Let it be Ashria model. Ashria model, yes. Okay. For Ashria model, yes. Let's run our model. Yes. This Ashia model is a little bit different. Okay. This Ekbal model. Ekbal model, it's different because it can estimate. It considered. Ekbal and Reuter and Paul considered ozone levels, scattered radiation in the sky, and water column, and so on. Let's go for 10 minutes interval. Okay, for China, yes. For one model, yes. Let's run it. Yes, it can estimate here direct normal radiation, okay, beam radiation, and diffuse, and this is a global. Okay, this is a global. Okay. Okay, suppose we are going to draw our results with time. This is okay. Current time was this is global. Let's go for yes, this sine curve from 8 up to 4 afternoon. Okay, I think this is our peak. It's around 680 or something like this. Let's see the value. Yes. Okay, we can emphasize this one in order to represent more data. This is the interval data. Every 10 minutes we have such configuration. Okay. We can adjust it again. Well, this is a total pole model. Yes, let's see pole model. But we have this one model. We can assign some specifications, such as friction scattering, water vapor column, single scattering albedos, ground albedos and sky albedos, vertical ozone time, temperature and pressure in millibar. And we can choose a ground albedo. It's desert, snow, ocean, grass, and so on. This will affect on the diffusion of the solar beam hitting the surfaces. Okay, this is for ball model. It's surface pressure, yes, and amount of water vertical column, and the same for ground and sky albedos. Let's go for, I'm choosing the first configuration. Let's see. Yes, direct normal. We are going to estimate direct normal. Yes, this is direct normal every 10 minutes from 8 morning. Okay, and this is a global radiation, and we can represent it. Yes, with current time. With a ball model, yes, representing this with time, and you can draw, and you can, sure, you can add more configurations. You can add more figures and compare between each configuration. Choose based on your specific location and so on. And sure, you can work on time limit and adjust the model. Adjust your entrance on this matrix according to clouds or sun conditions during the day. You can control it with I mean, we can transfer the model into a more dynamic to become more dynamic model and so on. Okay. As we demonstrated before, we have many solar radiation models we can add, we can deal with, we can connect between solar radiation models and other configurations such as solar fields and solar destination plans and anything which is depending on solar radiation. We can calculate it based on a specific location or the location of operation. Okay, don't forget to download latest publications on redslabel.com. Thank you for watching. Please like, share, subscribe. Thank you.